All right, guys, so we are going to practice dividing terms, polynomials, basically applying the quotient law of exponents. Okay, so I wrote the rule at the top of my notes. Make sure that you always do that and refer to it. So if the bases are the same, then you subtract the exponent. So we're going to show you how that rule applies in these 4 problems. Okay, so in this very first one, my base is 7. They're the same. So that means that I'm going to subtract the exponents. So I'm going to rewrite that as 7, because that's the base, to the 13 minus 5 power, okay? And then I'm going to simplify that even further. 13 minus 5 is, should have gotten that by now, 8. And then I have 7 to the 8th power, and I'm going to simplify that even further. I believe I wrote the answer somewhere right here. Yep, you should have gotten this bad boy. Boom. 5,764,801. Okay. So, oops, sorry about that. Okay. So only when it's a number for a base with an exponent would you simplify it. Okay. But for the rest of these examples, the same doesn't happen. So in model problem number 2, I have, again, the same base, W and W. And they're dividing, so that means that I can subtract the exponents. So I'm going to rewrite it with one base, W, to the 5 minus 4 power. 5 minus 4 is 1, so I can write just W. W to the first power is inferred because there's an imaginary 1 there, okay? Now for practice problem number 3, looks like we're taking it up a notch, okay? I see 2 variables and a coefficient for both the numerator and the denominator, okay? So when this happens, I'm going to take the alike things and divide them. So I'm going to focus, right? So I have 10 divided by 2. These 2 are like terms. 10 divided by 2 equals 5, okay? So my very first answer is going to be 5. Now the next one. So I have x to the 5th and x to the 3rd. They're the same because they have the same base. So x to the 5th minus 3 equals x squared, okay? So then I'm going to just write that over here, okay? And then finally, you guys can cross them out as you go, whichever way. Now finally, I have y to the 10th minus y. Again, there's an imaginary 1 here. 10 minus 1 is 9, so I'm just going to write y to the 9. Now, this here is my final answer because 10 divided by 2 is 5. 5 minus 3 is 2, which you got here, and then 10 minus 1 is 9, okay? So you're basically just combining the things that are alike, and you're making sure that you're simplifying or subtracting the exponents. Now, for this last one, we have one more variable than we did before, but it's the same thing. You line up the things that are alike, okay? So I have 5 divided by 2, a to the 3rd and a, b to the 10th and b to the 3rd, and c squared and c squared. Now, I'm not going to separate it the way I did here because this could become confusing. So I'm just going to do my math, okay? 5 can't divide by 2 evenly, so that is just going to say as 5 over 2, okay? A to the 3rd, and you know what? I can cross that out, okay? A to the 3rd minus a, that's like saying 3 minus 1. 3 minus 1 is 2, so that's a squared. Crossing it out, okay? Then I have b to the 10th and b to the 3rd. Okay, well, 10 minus 3 is 7, so this is b to the 7th. And then finally, I have a variable and an exponent that are exactly the same. Well, these 2 just cancel each other out, and it's not included in my final answer. So this here is my final answer, 5 over 2, a squared, b to the 7th, okay? Just make sure you copy these notes down, and you use these model problems as an example for your homework. All right, bye guys.